this is how to estimate a two-way slab. So here in the plan, you can see top bars, no, the layout for top bars and the layout for bottom bars. So this is just for a typical slab. We still don't know what are the spans. Now we have the shorter span and we have the longer span. So we look at the plan and try to analyze what slab will we use as a representative slab to represent for the type of slab that is being specified. For example, S1. No, if you look at here, we have S1, S2, and S3. So you take a representative sample of the S1. Then you take also a representative sample of S2 as well as for the S3. Now, why are we doing this? It's because especially if there are really large areas that you are going to estimate, it may be very hard for you to account for all those slabs. So what we do here is we just have to analyze one slab and we use ratio and proportion to account for all the similar slabs. Okay, so we take one slab 1, we take one slab 2, and we take probably here one slab 3, and that will represent all the other areas where those slabs can be found. So for S1, I will take this area. I will just use this marker for slab 1. For slab 2, I will use this one, and for slab 3, I will use this area. Okay, so let's now analyze slab 1. Slab 1 has a dimension of 4.5. This is the exterior dimension of the beam. 4.5 from this point to the other point. We just take it as an allowance, no? Then here from this point also to the other edge of the beam, 3.5. So we set up now our Excel format for that. Let's say S1, and then the location, we specify the location based on the grids. So DF and 1, 2. So DF 1, 2. DF slash 1, 2. For the quantity, we just use one slab. And then for the concrete, I will use the dimensions having the allowance, because the dimensions are not center to center dimensions or clear span to clear span, but exterior face of each beam. Say this one, 3.5 is coming from here to the other end. So we have 3.5 here, and then 4.5 on the other side. Then for the Z dimension, let's take this one to be the thickness of the slab. So let's look at the slab schedule here. We look for the slab schedule and we look at S1 and look at the thickness. The thickness of S1 is 100 mm. So we have 0.1 because our units here are in meters. For the volume, a simple length times width times height will do. And for the total volume, of course, the volume of one slab times the quantity. In this case, this is just 1. Okay? Now, for the rebars, let's classify the X direction and the Y direction. Let's also classify the top bars and bottom bars, and let's also classify the continuous bars and the discontinuous bars. Okay? So, we have quite a number of rebars to classify here. So Y direction, I will use the Y direction first. Top cut bar, support A, Y top, cut bar, support B, no, on the other side. Continuous, Y top continuous. Okay, so those are the rebars at the top bars. Now copy this one and then bottom. Now also account for the bottom. Y bottom. Later on you will know that some of the entries here will have no rebars. Now that depends on the type of slab. So bottom, cut bar, support B, and then Y bottom continuous, and then you have another one which is Y bottom midspan. Okay, so those are the type of rebars that you can see along the Y direction. Now in the X direction, we just have to copy this one, then replace everything by X direction. Alright, next we have diameter. The diameter to use is 10. Now almost all the rebars here are having diameter of 10 mm. So we use 10. And then we drag it all the way down here. Then for the weight per linear meter, let's look at our standard. For the 10 mm, the unit weight is 0.617. So drag it all the way down. Then for the number of pieces, you look at the schedule. For the top bar, at one end, at one support, along the short direction. Okay, you look at the spacing along the short direction because that will tell you the number of rebars along the long direction. Okay, you look at the spacing at the short direction so that you will know the number of rebars along the long direction. Okay, so we have a spacing of 100. So since the spacing is 100, we look at the short direction, which is 3.5 divided by 100 or 0.1 because the unit here are in meters. So 0.1. So there are 35 pieces of cut bar in the Y direction. Now that is in support A. Okay. Now along the other support at the discontinuous edge, still the spacing is 100. So we follow that one again, equals short direction divided by 0.1 or 100. So still we have 35 pieces of rebars. Is there a continuous? No, there is no continuous here at the top bars. So that will be 0 entries. How about for the bottom bars? Is there a cut bar? If you analyze here, for the bottom bars, the spacing here is 200. The spacing at the midspan is 200, as well as here 200 gyapon. So therefore, there is no cut bar. There are only continuous bar at the bottom. So 0 cut bar, 0 cut bar, and then we have continuous bar. So for the continuous bar, that will be 3.5 divided by 200 or 0.2, because the spacing here is 0.2. Okay? Now, is there a midspan? Is there a rebar at the midspan? No, because the spacing here is 200, 200, and 200. So there is no difference at the center and at the sides. So therefore, there are no extra bars or midspan rebars. Alright? So I hope that is very clear. Let's now proceed to the X direction. For the cut bar at support A, so similar to the procedure of the Y direction, so you just have to analyze the spacing here. Along the long direction, 150, another 150. So equals 4.5 divided by 0.15. Okay? On the other side also, 4.5 divided by 0.15. So 30 pieces each side. Then for the top continuous, as you can see here, there is no spacing. So it has no rebars. Let's look at the bottom. For the bottom, you will see here 10 at 275, 10 at 275, 10 at 275. It means to say that there is no extra bar at the midspan. So since there are no extra bar or cut bar, so that will be 0, 0, and then there is a continuous rebar having a spacing of 275. So equals 4.5 divided by 275. 0.275. So 16. And at the midspan, there is none. So that will be 0. So it's not that difficult, no, because there are a number of standard rebar entries here that is not filled up. Alright, so we now go to the length. Length is L over 4 for the cut bars. If you look at here, the length is L over 4, LA over 4, LA over 4, or simply L over 4. So what is the length? The length is 4.5 divided by 4. Okay? The length is 4.5 divided by 4. And for the other side, still we have 4.5 divided by 4. Okay? And the continuous, for the Y continuous will be just simply equal to 4.5. For the X, we have 3.5 divided by 4. Here we have 3.5 divided by 4. And the continuous, we have simply equal to 3.5. Alright? Now, I'm sure there will be allowances. And that's up to you at the end. But here, we just place the actual measurements since the measurements in the X and Y already have allowances. If you try to recall, the X and Y dimensions that we have taken from the plan has already an allowance because it is measured from the outer edge to the outer edge of the other slab. So that will serve as your allowance. That's why we are placing here the actual measurements without allowance for hooks or bends. Okay, then for the weight, that will be simply equal to the weight per linear meter times the number of pieces times the length. and then you just have to drag it down to the other rows. Then for the total weight, that will be the weight of this individual rebar multiplied by the quantity. Now, to lock in the quantity so that you will not you will be allowed to drag it down, you press F4, and once you press F4, there will be a dollar sign at the cell that you want to lock. Okay, so once you press enter, you can now drag the formula down to the last row. Alright, and as to the formworks, we just have to measure the area or the surface area. No, so the surface area is 3.5 times 4.5, and then for the total area, you have this one times the quantity. Okay, so you now have the total volume. Let's drag the formula down below, or add the formula here to have the totals. And then total weight 164, and the total formworks is 15.75. Now, why are we trying to get the total? Because from the total, we will get the statistics. Here, the volume is 1.58, and then the total weight of rebars is 164. So therefore, for every cubic meter, now if we try to divide this one, the total weight divided by the volume, we can say that for every cubic meter of concrete, there will be 104.703 kilograms of rebars. Okay, and then if there is another S1, in which it will be too time consuming to analyze. Let's say there is another S1 with another dimension, maybe a trapezoid or whatever dimension. Let's say we have here another slab which is 3, and then we have 4, and still with a thickness of 0.1, and of course with volume also. You can already stop here. And then for the rebars, total rebars, you can just specify the weight based on the proportion of the sample S1. So what is the weight? That will be 1.2 times 104.703. So you will have 125 kilograms. Okay? So that's how to estimate for the slab.